Let's suppose your friend places a set of two balls and a stick on the table. He asks you to separate the two sets using the stick. The first solution seems to be quite straightforward, where you will place the stick somewhere in between them, and it could be done in various ways. Now say we place an additional green ball on the table. Your stick will have to be rotated slightly to fit the solution. After this, you're thrown with a different kind of problem. Your friend jumbles up all the balls on the table. What is it that you would do now? One way could be to take a chalk and draw a line like this. But there's a problem with this. This is not linearly separable. There's another way. We could take all the balls in a basket and throw it up in the air. When the balls are up in the air, you take a sheet of paper and throw it like a samurai such that it is able to separate the two sets or the two classes in an optimal manner. Machine learning today allows us to perform such classifications with some algorithms. In a scenario like this, we can use support vector machines or SVM, which is a supervised machine learning algorithm. SVM is a linear model for classification and regression problems. It can solve linear and non-linear problems and works pretty well specifically in the case of classification problems. The intuition of SVM is simple and straightforward, where we create a line or a hyperplane that separates the data into classes. Let's atomize this further to get a stronger understanding. In our initial case, which is a linear problem, there can be multiple ways of placing the yellow stick to divide the two classes of balls on the table. But this seems like the most apt solution. These 2 points, which are the closest to the separating line, are known as the support vectors. And these are the closest data points from each of the two classes we are trying to separate. This distance is known as the margin, and the objective of SVM is to maximize this margin between the support vectors and the separating hyperplane. Once we get the line, our classifier is ready. Then depending on where the testing data lands on either side of the line, that's what class we can classify the new data as a green or a blue ball. In our second case, we have a non-linear problem. Here the balls on the table are known to be in something called the input space, and when we throw the balls in the air, it is known to be in the feature space. The plane shaded in yellow here is the separating hyperplane. The most important point is this process of moving from an input space to a feature space, which is moving the balls from the table to a higher dimension space, which is the balls in the air. This step is ideal to separate our data points and is known as kerneling or the kernel trick. The kernel sounds like it's something complex, but it's a mathematical function that helps transform our data from one-dimensional space to another higher dimensional space, and in this case, it helps us move from a two-dimensional to a three-dimensional space. By doing so, we can separate our points in the higher space with a hyperplane. If we were to take a look at this solution from the top, you know what is it probably going to look like? Our initial solution. Some important points for us to remember are that kernel functions can be of multiple kinds. They help us make computations faster by moving our input space into a higher dimension, which is actually easier for us to separate. They do not separate the data for us. Also, there is no one-size-fits-all solution. Different problems require different solutions and different kinds of kernels. Hope you enjoyed this video, and in case you would like to get such fun and intuitive explanations to other machine learning algorithms, do check out the playlist I have created for machine learning. Do not forget to like, share and subscribe. Your support will help improve the overall quality of these videos, where we break down things into their most indivisible form, atom by atom.